Hello and welcome back. In this video, we're going to be learning how to do greatest common factors. A greatest common factor is another way to find and simplify fractions. For example, if you look at this number pair, let's say we have the numbers 3 and 6. Finding the greatest common factor between these two numbers is the same thing as saying, how can we find the biggest number that both numbers can be divided by? In simple pairs like this, the answer is pretty easy because when you look at it, you're trying to say, okay, what can I divide 3 and 6 by so that they both turn out to be perfect division. So, for example, factors of 3. A factor is another way to say what numbers can that number be divided by. So, for example, let's try to list the factors of 3. Those are, so basically we're saying what numbers can we divide 3 by and have it fit perfectly in. The factors of 3 are 1 and 3. The factors of 6 are 1, 2, 3, and 6. You're going to notice that every number has at least 1 as a factor and itself as a factor, because every number can always be divided by 1 and by itself. And then these middle numbers are depending on the number. So we see that both numbers, both 3 and 6, can be divided by 1. But we also see that both 3 and 6 can be divided by 3. 3 can't be divided by 6 because you see it's not in the factors of 3. So basically we know that 3 is the greatest common factor of 3 and 6. That's what a greatest common factor is. Now let's look at a different pair of numbers. Let's look at 2 and 3. You don't have to write out the factors, but if it's like a simple number, you can probably just think of them in your head. So let's look at 2 and 3. The factors of 2 are 1 and 2. The factors of 3, we wrote down before, are 1 and 3. So it doesn't seem like they have anything in common except for 1. So therefore, 1 is the greatest common factor. And I'll write that as greatest common factor equals 1. Let's try a different pair of numbers. Let's try 4 and 5. The greatest common factor, or the factors of 4, are 1, 2, and 4. The factors of 5 are 1 and 5. Again, they don't have anything in common except for 1. So 1 has got to be the greatest common factor. Now let's try the numbers 6 and 9. The factors of 6, we can write these out if you can't keep track of them in your head. So the factors of 6 are 1, 2, 3, and 6. And the factors of 9 are 1, 3, and 9. If you have a number like 9, where you can do 3 times 3 is equal to 9, you only count 3 once. It doesn't make a difference, but just so you know, you only write 3 once. And now you see what they have in common. It looks like they have 1 in common, and they have 3 in common. So, since 3 is bigger than 1, 3 is our greatest common factor. Now let's try the number combination of 3, 6, and 12. It doesn't have to be a pair. It can be any group of numbers. We're just looking to see the biggest factor that they have in common. So for 3, our factors are 1 and 3. For 6, it's 1, 2, 3, and 6. And for 12, it's 1, 2, 3, 4, 6, and 12. Another thing you'll notice about the factors of a number is that they pair up. So if you look at for 3, it's obvious which two numbers are the pair, these two. For 6, you'll notice that 1 and 6 pair up, and 2 and 3 pair up. And by pair up, I mean that when you multiply them together, they get you 6. So 1 and 6 gets you 6, and 2 and 3 multiplied together also equals 6. And for 12, you'll notice that 1 and 12, 2 and 6, and then 3 and 4. This is a great way to check if you've gotten all of the factors when you're trying to list them out in your head. You just have to know that there has to be an even number of factors. Or, no, sorry, that's not right, because if you look here, this is 1 and 9, and then 3 but with itself. But you have to make sure you cover all of the bases by checking using this method, the pairing method. And then check if you have an odd number of factors, check if you can multiply the middle one by itself to get to the number, which is called a square. So now we have these factors, and we're trying to see what's the biggest factor that can get to that all of them share. In this case, it still looks like 3 is the biggest one for all of them. So that means that the greatest common factor is equal to 3. Now let's try another example. What if we try to do 3, 6, and 10? So for 3, it's 1 and 3. For 6, it's 1, 2, 3, 6. And for 10, it's 1, 2, 5, and 10. All three of these have 1 in common. But besides that, that's it. You don't see 3 is in these two, and then not in this one. You have the number 2 in 6 and 10, but not in 3. So 1 is the greatest common factor. Now let's try one more example. We're going to try the numbers 5, 6, and 7. For 5, our factors are 1 and 5. For 6, it's 1, 2, 3, 6. For 7, it's 1 and 7. Again, if you look at these, there's nothing in common except for 1. So again, our greatest common factor is equal to 1. If you notice numbers like 5 and 7, do you see how they only have 2 factors? It's 1 and itself. And we said before that every number is going to have both 1 and itself as a factor. But for numbers that only have the factors of 1 and itself, those are special numbers. We call numbers like 5 and 7 prime. And 7 is also prime. This is just something a little extra to know, because prime numbers, there are small prime numbers and there are also big prime numbers. And in general, you will know they're prime because, again, they only have 1 and they're themselves as factors. So that's how to find greatest common factors. Thanks for listening, and see you next time.